Okay, YouTube, in this video we're going to be introducing the law of cosines. And the law of cosines is a law that is commonly used when solving triangles, and not necessarily non-right triangles, but typically with non-right triangles, because with right triangles we tend to work with just our basic trig functions, but the law of cosines is used when solving typically oblique triangles. And it kind of partners with the law of sines. Okay, so in this video, exploring the law of cosines, let's go ahead and start by pointing out what the law of cosines is. There are three different forms, three alternate forms of it, but given some triangle, we'll draw this triangle ABC, where you see here C is our largest angle. You'll notice that we give the capital letters to the vertices here, A, B, and C. And the lowercase letters, for example, lowercase a is the side opposite from our angle A. So we say this is the typical setup for a triangle. If this is our triangle here, then the law of cosines, let's go ahead and start with this first one, is a squared equals b squared plus c squared minus 2bc cosine a. Before we take a look at the other two forms of this law of cosines, let's go ahead and start by looking at this first one. I often get students saying, how in the world am I supposed to remember this entire formula? And so here are a few things I'll point out. Starting with this, we say a squared. Okay, so if we're starting at a squared on the left, you notice that a squared is equal to b squared plus c squared. Now, this is a non-right triangle case that we're working with here, but it's fair to say this. A squared equals b squared plus c squared is very Pythagorean-like. So if you can remember the Pythagorean theorem, then we say, well, then whatever squared on the left, it equals the square of the other two sides summed together. Advancing past this, you'll notice all three forms of this formula here have minus next, minus 2 times two numbers here, two side lengths, and these side lengths happen to be b and c in this first part. How do I know b and c? Well, they were the same two numbers that I just ended up squaring on the right here anyways. So if I said a squared equals b squared plus c squared, which is Pythagorean-like, immediately following I know it's going to be minus 2b times c. And then last but not least, we have a cosine tacked onto the end of all of these formulas. And you'll notice that we're taking the cosine of a on this first one here. Whatever angle this is here, angle A, that must have been the same thing as at least the corresponding side length or opposite side length on the left here. So if we started the formula with a squared, we're ending with cosine of a. If we started, say, the formula here on the second one with b squared, we're ending with cosine b. And so just kind of start to think about why these formulas appear the way they do. Okay, so that being said, let's talk about the intent for using the law of cosines in the first place. So that is, let's go ahead and say there exists a triangle ABC, and we'll say we've got certain given information about this triangle. That is, we know that angle A, will go with a common angle here, 60 degrees. How about lowercase b, or side length b, is 20, and we'll go in inches. And how about C? C, we'll call it 30 inches. I like when C is the longest side length. So let's go ahead and construct a triangle that's going to go with us here. And then we'll go from there. So we say our triangle, just some arbitrarily drawn triangle, sketch us in. We'll label our vertices inside. So we say C up here, we'll call this A, we'll call this B. And so lowercase a, we've got lowercase b and lowercase c. And filling in the known information, we know that C is 30 inches. We know that the side length B is 20 inches. And we know that angle A is 60 degrees. So the first thing I want to consider here is this. The law of cosines is markedly longer than using the law of sines, which is a very, very simple proportion setup using sines. But the bottom line is this. When you use the law of sines, you have to have an angle side pair. And what I mean by this is we know angle A. That's not enough to determine angles B and C. But we know angle A. We do not know the length of the side opposite. Otherwise, we'd be using the law of sines here. So it is the case that, you'll notice I titled this video the angle side angle case. When you have two side lengths and an included angle, that is the angle between them, or angle side angle, then we use the law of cosines. So let's go ahead and get this set up. And let's start with this. Let's say we know side B, we know side C. The side we want to determine here is A. So since we're going to do this, we'll use this first form of the law of cosines up here. And so setting this up, we have it as follows. We say A squared equals side length squared plus side length squared. So B squared plus C squared minus 2BC cosine of A. So we're going to fill in the known information now, where we said B is 20 inches. Okay, so we say 20. C is 30 inches, we'll call this 30, and then we could say, just like we had mentioned, when you remember this up top, whatever these two numbers are, this is the same two numbers that you subtract next to your 2 here. And then the cosine of A, we know angle A is 60 degrees. So we're using all the given information. The only thing we don't know here is A squared. So going ahead and working with this now, we get this. Clean this up a little bit here. We say A squared equals 20 squared, which is 400. So we have 400 plus 30 squared, which is 900. Minus 2 times 20 times 30. So 20 times 30 is what? 600, and double that. So we say minus 1200 of these cosine 60 things. So now for the sake of convenience, we know the cosine of 60 to be a half. So let's clean this up even further. We say a squared equals 400 plus 900, which is 1300. Those give us this 1300 here. And we can use a calculator for any of this. But minus 1200 times cosine of 60, which is a half. So we say a squared now. Furthermore, it's 1300 minus half of 1200, which is 600. And 1300 take away 600 leaves behind 700. So now we finally end up with this. We say, well, then this would all imply that if we took the square root of both sides, square root of both sides of this, we say a squared of a squared is a square root of 700. Then we get this. We get a equals the square root of 7 times 100. The only reason I mention this is because we can get an exact value on this problem. But we say that is 10 radical 7. So 10 radical 7. So now I do actually want to get a decimal on this one, talk about reasonability of answers, but 10 times radical 7. And we crank out this decimal that is approximately 26.5 units long. So now in terms of units, we say A. A is approximately 26.5 units, and we were measuring this in inches. So first thing we want to do is we want to take this value and put it back up here on our diagram and talk about, is this reasonable? So we say about 26.5 inches. We can also write this over here as approximately 26.5 inches next to our index of values over here. And so we say 26.5 inches opposite a 60-degree angle. This is very reasonable because that is the intermediate side length. It's kind of in between side length B and side length C, which were 20 and 30 inches respectively. So from here, if we're going to solve this triangle, now we need to go back and solve for angles B and C. And the good news is this. Once you use the law of cosines to determine the side length A, then we have an angle side pair, kind of as we previously mentioned. And what this does is it opens up the possibility of using the law of sines, which, by the way, recall the law of sines said this: the sine of angle A divided by the side length opposite A has to be the same thing as the sine of angle B divided by its side length opposite, and likewise with sine of angle C divided by its side length opposite. So since we have angle A and side length A, it's fair to say this. We say, okay, so the sine of A, which is 60 degrees, over the length of its side opposite, which is 26.5 inches, is equal to, and let's go after, say, angle B here. So we say sine of B, and that is over side length B, which is 20 inches. So now all we need to do is determine this value of B. So since this is a proportion, we'll go ahead and do a cross product here, and we end up with this. We say 20 sine of 60 degrees is equal to 26.5 sine of angle B. So now all we need to do is divide by 26.5, and that'll isolate our sine B, so 26.5. So we have sine of angle B is equal to 20 sine 60 over 26.5. So we'll pull out our calculators now. 20 sine 60, enter, and we were dividing this by 26.5. So now, because we haven't got the angle yet, we've just got a decimal value, I'm going to take this out a few places, 0.6536, so 0.6536-ish. So 0.6536-ish. Now, in order to solve this, we'll just undo our sign by taking the sine inverse of both sides. So we say sine inverse of this quantity on the right is the sine inverse of this quantity on the left is our angle. So we get this. We say B is approximately sine inverse of that value we just found. And so we'll do sine inverse of this value, and we get an angle, about 40.8 degrees. So I'm going to call this 41 degrees-ish. But we say, well then, angle B, using the law of sines now, is about 41 degrees. We'll fill this in over here. Angle B, 41 degrees-ish. And we can fill that in on our triangle. So the nice thing about this is this. We only had to use the law of cosines the first time through. Once we used the law of cosines, we were able to set up with the law of sines an angle side pair proportion and determine this second to last angle. So now that we know these two angles, actually, we know that all three angles in a triangle must sum to 180. So it's fair to say this. If 60 plus 41 is 101, then we can just determine angle C by taking the total of 180 degrees in the triangle and subtracting off that 101 that we get there. And we're left with the remaining 79 degrees, which, filling this in up here, 79 degrees, C is approximately 79 degrees, is an extremely reasonable answer, all things considered. So this is just kind of a quick run through of what the law of cosines looks like, how you remember it, how you use it, and the fact of the matter is this: you'll only ever have to use it one time, because after that you can use the law of sines to find the remaining values in the triangle. Cheers.